Okay, so there's a question before class about logarithmic differentiation, which is 3.6. And I'm going to just pull up an example that we did in class, if I can find one from the notes. Yeah, so we talked about logarithmic differentiation back in chapter 2. And now we're applying it to when we have a limit that's in an indeterminate form of like 1 to the infinity power is probably the most common type one. So if I can pull when we did 3.6. Okay, so we're looking for indeterminate forms of type 0 to the infinity, infinity to the 0, or 1 to the infinity. It's indeterminate, so I cannot evaluate it by itself. So to apply L'Hopital's rule, I have to manipulate it in a form of 0 over 0 or infinity over infinity. So the approach on this problem is to write y equals the function, so f of x times g of x. If I take the natural log of both sides, I can pull this g of x down and have g of x times the natural log of f of x. Right? Does that make sense? Now when I'm on this form, I'm in infinity times 0 type of indeterminate form. An example of that, in this case, we know this limit to be e. We've manipulated a lot. But to show that, we could write y equals this function. If I take the natural log of y, I bring the exponent down, I have natural log of the function. So at this point, I have ln of my function over x. So I don't have to manipulate it because it's already in the form 0 over 0. But if this was just x, I would have to bring it down to be x to the minus 1, right? So then I have 0 over 0, so I don't have to do anything more except take the derivative. I take the derivative of the top separately from the derivative of the bottom. Some of you are trying to use the quotient rule, which is so much more complicated and messes up the problem. So you just take the derivative of the top, which clearly is 1 over x, or 1 over 1 plus x. The derivative of x is 1. So if I evaluate this as x goes to 0, which was what the original limit was going to, I have 1 over 1 plus 0. Which goes to 1. So that tells me the limit of ln of y is 1. Therefore, the limit of just y is e to the first power. Does anyone have any questions on the methodology on that and how that works? Question?
There's one on the written homework, number 27. It's 1 minus 3 over x to the x.
Okay, what number is this?
27.
27. The limit as what?
X goes to infinity of 1 minus 3 over x to the x.
So I'm going to give you your quiz right now. This one's on your quiz. So I gave the same quiz, and I think it would be kind of unfair to the other class to give you guys the answer when you guys put it on the quiz. I gave you the form. The application of it is part of your quiz. So this one is exactly on your quiz. So we'll take the quiz first. Then I'll go over this one. You guys have the tools to do this one. This one was on Wiley as well, but that will be different. For some of you, it might be the exact same. So it's on your homework as well. You can write it for your written homework. Not too bad. Don't be mad at me. One comment on the quiz I really didn't go over with you guys. It's been something. I pulled this from the book questions. On number 3, it's actually not even number 3, but what should be called number 3, it asks you for a delta y as well. Don't worry about doing delta y. You get some points there. You just find dy. And when you are done, turn it in. I'll give you guys. Give you 15 minutes from now, so.
take me out to eat over the weekend, he said they got it, what they call it, internship or something. They got open for you, if you want it. Well, like, Brady told me, big dude, the big dude that worked with me, he said he'd talk to you about it. Every time I seen you, and I told him I ain't seen you all week. But they got some kind of open for the engineers, yeah, the engineers. When you go, when you work, while you go to school, what they call it internship or something. He said the dude said he got some openings that help you get on. They might have this weekend. He told me if I see you, tell you to holler at him. He's the boss, so I don't know where he got around the corner. You know,
Oh, you're fine.
much.
Is that even close to what we're talking about there?
It's a lot easier than that. Just find dy dx and then solve for dy. But
Like that?
yeah.
Oh.
Yep. Perfect. All right, you guys need to turn your quiz in. All right, time's up. So turn in. All right, so I think it's worth some time since you guys have taken the quiz. We could just go over it, and then it'll be fresh in your mind because by the next time I see you, you'll have spring break. And each one of these concepts will be on your next exam, and each one of these concepts generally shows up on the final exam. There's always an application problem on the final exam. There's always, well, I wouldn't say always, there's generally a local linear approximation, if not find the equation of the tangent line problem. And then there's always a L'Hopital's rule problem. And in the past, I've seen one similar to this. This was a homework problem. It was on Wiley. A lot of you knew the answer, e to the minus 3. But you didn't know how to show it. So let's go through and look. Did anyone have any questions on number 1? So the setup of this problem, I have a ladder that's 13 feet long up against a wall and the ground. So I can call the wall side wall W and the ground side G. So G squared plus W squared is 13 squared. So if I differentiate this with respect to time, if I freeze time, then I have 2G times G dg dt plus 2W times dW dt equals 0. So this is my relationship between these related rates. I'm given that dW dt would be minus 2 feet per second. It's sliding down. It's decreasing. So I know dW dt. And I'm also given when the incident time, the wall is 5 feet. So when the ladder is 5 feet, how fast will G be changing at the incident time when the ladder is 5 feet above the wall, or 5 feet on the wall? So I need to find G given when W is 5. So really I have this triangle. I have 13, 5, and G. So it turns out G is the square root of 13 squared minus 5 squared, which is square root of 144, which is 12. So I'm given G, or I could find G. I was given W and dW dt, and I want dg dt. So that's minus W over G times dg dt, or dW dt, sorry, dW dt. So that's minus 5 times minus 2 over 12, which would be 5/6 feet per second, but don't worry about units if you didn't have feet per second. Any questions on that? So the level of difficulty on this one is maybe one tier above just the related rate problem because you have to go about and find G. You can't do the problem without finding G. A lot of related rate problems that show up on the final exam are relatively simple. You don't have to do that extra tier if everything's given that you need. You just get the right formula, you differentiate it, and you plug in what's given from the problem. Local linear approximation. So if I want to approximate the function, would be something to the 4th power. So the value of the function is going to be about the point 3. So I have the value of the function at 3 plus the derivative of the function at 3 times x minus 3. So if I want to approximate the function at 3.02, I have 3 to the 4th plus 4 3 cubed times 0.02. What should I forget? This is approximately 81 plus 108. 108 times 0.02, which is approximately 83.16. So once you know the formula, you just plug that in your calculator.
That'll always be the point slope formula?
This is the approximation of the tangent line.
Sure.
So it's a local linear approximation. So it's one way to write point slope form. Generally, point slope form is in the form y minus f of x
Sure, yeah.
equals the slope times x minus x1. So this is at x1 and this is at what x1. So we don't get confused. The x in the equation in the x point, which would be x1. But they just added this to the other side and solved for y, right?
Sure.
F of x1 plus the derivative at x1 times x minus x1. So it's
but-
the exact same thing.
Yeah, so I'm just asking, so in a local linear approximation problem, it's always the point slope formula.
Yes. What you're doing is you're writing the equation line, which you can do with point slope. You have a point and you have a slope.
Yeah.
But you do it about the point that you know.
Exactly. Well, and about the point that you were approximating from the original.
From the original, yeah.
Okay.
Number 3. Number pen that leaks through. On number 3, which I didn't number at number 3. I lost my number 3. I just wanted you to find dy, which dy over dx would be 3x squared. So if I solve for dy, I have 3 times x squared times dx. So if you got that, you'll get your full points. Delta y has to do with knowing that the formula for delta y is f of x plus delta x minus f of x. And I really didn't cover that. Delta y is not necessarily calculus, it's algebra, right? So, no. If I have a function here, this was just in the development of the class, and I just pulled this from a homework problem, and I didn't necessarily pay too much attention. So here, if I call this f of x, and this is f of x plus delta x, right? So this would be x, comma, f of x. This would be x plus delta x, comma, f of x. So if I want to do the change in y, I do this minus the original function, which makes sense, right? If I was to look at the picture at college algebra. So I'm changing x from x to x plus delta x, some distance. So this is pretty straightforward, I think. So if I was to plug this in, I would have x plus delta x cubed minus x cubed. So if I wanted to simplify that, I could use the Pascal's triangle to get this to be x cubed plus 3 x squared delta x plus 3x delta x squared minus delta x cubed minus x cubed. The x cubes would cancel and be left with this. If anyone did that, which I don't foresee anyone doing that since I said don't do it, but I could give bonus if that happened. But the limit as x goes to infinity of x over e to the x, what's that go to? You don't have to show any work there. That's clear that it goes to 0. That was a theorem. That was a theorem in the book, right? We proved that. The book proved it. We didn't go over the proof, but the book proved it by using L'Hopital's rule as much as it needed to. This example, okay, a lot of you are like, I know this is the answer, but I don't know why it's the answer.
I didn't even remember the answer.
Well, some of you am. So let's look at doing this one. Y equals this function, right? So if I take ln of y, what do I get on the right-hand side? Very good. So if I'm taking the limit as x goes to infinity of x times ln of 1 minus 3 over x, this is type infinity times 0, right? Because ln of 1 is 0. And this is going to 1 as x goes to infinity. So I need to manipulate this to be in 0 over 0 or infinity over infinity. One way to do that is to pull this down in the denominator and make the exponent negative. So if I do that, I have the limit as x goes to infinity of ln of 1 minus 3 over x to the minus 1. Now I'm true type 0 over 0. So I can apply L'Hopital's rule, and if I apply L'Hopital's rule, I get the limit as x goes to infinity. On top, I get 1 over 1 minus 3 over x times 3x the minus 2, because that's the derivative of the inside. The derivative of the bottom would be minus x the minus 2. That would cancel. Then I'm left with the negative. I can pull that up. I get the limit as x goes to infinity of minus 3 over 1 minus 3 over x, which gives me minus 3. That's the limit of ln of y. So therefore, the limit of y is e to the minus 3. And that's how we get our answer there. So keep in mind, I take the best 8 quizzes. This is quiz number 7. We definitely have more coming up. So that being said, I want to put you guys in the situation of this is a test-like atmosphere. So when you get to the real test, you're like, I've been in this situation before, and hopefully you can learn from being in this situation. And when you get to the exam, it's not like you're in this new situation before. So I want to test you as much as I can so you get used to it. So then on the test, it's no big deal. And on the final exam, you've already had a quiz on it, you've had an exam on it, and then the final exam is the 3rd time you've been in that situation. So hopefully you can, I don't know, remember what it felt like to be in this situation and be clueless. So now you're going to take it to be in this situation and gain from it. Question? How many points do you order? 1 billion. B. So this is divided up. There's going to be 9 points here. Probably 6.
6 on B.
Yeah, and 3 for A. A is...
Excuse me, how can I distinguish whether it is 1 minus 3 over x or 1 minus 3 over x?
Okay, so if I have 1 minus 3 quantity divided by x, that would just be minus 2 over x. Right? 1 minus 3 over x, the 1's by itself, minus the 3 over the x.
Okay.
Right? This would be minus 2 over x. Which is different there. Question? No, you don't need to. Yeah, once you have this, it's clear that the answer is going to be E to that answer.
So I forgot to use the element when I got minus 3.
So if you got minus 3, you'll get majority of the points. So you might, granted you did everything right, not that you just got minus 3. So yeah, that's another thing, putting you in that situation, knowing this is what happens. So when you get to the exam, the final exam, you know to use that e to the power. Okay, so we don't have too much time left, but I do want to talk about some problems in... Okay, this is going to be my 321. So we haven't talked about oblique or curvilinear asymptotes, and really the application of this would be just to find them, not to necessarily graph them. So it turns out when I have a polynomial in the form p of x over q of x, if p of x has a higher power, you can always use division. So let's look at an example. If I have a function f of x equals x squared plus 1 over x. So this one's really easy to divide because x is just x. The factor is x. So if I looked at the end behavior as x goes to infinity, clearly it goes to positive infinity, right? And as x goes to minus infinity, it goes to minus infinity. So I know there's no horizontal asymptote, but that doesn't mean there's not a curved asymptote where I'm approaching some function. And anytime you have the polynomial in the numerator the power of x is higher than the power of x in the denominator, you have the potential to have a curved asymptote. So if I divide this out, I can have x squared over x plus 1 over x. So I really have x plus 1 over x. So what this is happening here, f of x gets closer and closer to the line y equals x as x goes to infinity and x goes to minus infinity. Right? If I take the limit, they're going to go to infinity or minus infinity. Both these functions, these are the same function, just a different way to write it. So if I was to graph this, then I have this oblique asymptote here at the line y equals x. So I have something that looks like this. This function is going off to infinity, but it's getting closer and closer to this curved line. You might have to end up doing long division to find any curvilinear asymptotes. So let's look at another function. Let's look at g of x, where g of x is x cubed minus x squared minus 8 over x minus 1. So what would the end behavior go to? As x goes to infinity, the function is also going to go to infinity, right? If x goes to minus infinity, what's the function go to? Well, the highest power of x is cubed over the x, so that gives me x squared, which goes to infinity, right? So the end behavior is going to both go to infinity, but it's going to approach a curved line. So doing long division, I have x minus 1 divided by x cubed minus x squared plus 0x minus 8. So this here would be x squared. So this gives me x cubed minus x squared. When I subtract that, I get 0 plus 0x minus 8. So another way to write g of x cubed minus x squared minus 8 over x minus 1 would be as x squared minus 8 over x minus 1. You guys remember doing long division like this? Long division of polynomials? So that is telling me g of x is getting closer and closer to this line x squared as x is getting larger and larger, right? Because as x is getting larger and larger, this term is going to go away. So g of x is getting closer and closer to x squared as x goes to infinity and as x goes to minus infinity. So that would be your curvilinear asymptote. If we looked at the graph of g of x, so this is f of x. Let's look at g of x.
So is the x minus 1 only under the 8?
The x minus 1 is only on the over the 8 here. If I wanted to find a common denominator, I would get back this expression.
Okay.
Right? Here, if I do long division, I get this. So this gives me the form of when x goes to infinity, this term is essentially going to go away. And I'm going to get closer and closer to this x squared. However, the original function has a vertical asymptote at 1. Right? So it's undefined here at 1, at x equals 1. I have this quadratic asymptote. So the graph of this function looks like this, where it never crosses this x equals 1. But on this side of x equals 1, it's going to come down here. But the graph is going to have to flip around at some point and approach, this is going off, right? So it's going to have to approach this line here. So here it's going to approach, on this side it's going to approach minus 1, but if it's going to go away from it, at some point it's still a function, so it has to pass the vertical line test. And this is a quadratic function, right? That goes off to infinity. So eventually this is going to come back to approach that curve x squared. And honestly, you're not going to have to graph these. You're going to have to classify them. So on the written homework that I emailed out, it said something like, find all horizontal, vertical, and oblique asymptotes. So there might not be a horizontal asymptote. There might not be an oblique asymptote, but you have to have the ability to find it if there is.
And by looking at the graph of the equation.
The equation. So here, is it clear that the oblique asymptote's at x squared? And there's a horizontal asymptote at x equals 1. Sorry, vertical. There's a vertical asymptote at x equals 1. There's no horizontal asymptotes. Question? The written homework will be due the same time I collect the homework for the material on the third exam. So you want a date?
It's just before the fourth.
It's before the third exam, and the third exam is going to be the third 4/11. So the written homework will probably be due. I'll probably give you that Monday to turn it in, give you that weekend. So if I can give that back to you before the exams, so probably 4/8 is a tentative. 4/4, if you want to get it back on Monday, you can turn it in by 4/4. That Friday 4/5. So the exam, the next exam, is going to probably cover up to 4.5. So we've done 3.5, 3.5, 3.6, 3.4, 3.5, 3.6. Well, your quiz is over. 4.1, 4.2, 4.3. And then probably 4.4 and 4.5 for the next exam. So
That's the homework will be through as well.
yeah. So if you got it taken care of on the break, come back. Your schedule is going to be lighter. If not, you'll have that week to do it. But all right.